So if we check with this following practice, what the question was saying was to prove that this infinite series diverges. I want to show that this infinite series diverges. But here's the thing. Every time you want to show divergence, you might want to start with the divergence test. It's a quick start, right? It's a quick start. So you want to look at the limit of the sequence. And if that's not if that's not 0, I know my series is going to diverge, yes? So if you put it here, it's a 3 to the power 1 over infinite, which is 3 to the power of 0, which is 1, you feel me? So I know that it's going to diverge for the series, right? Because of the divergence test, it doesn't go to 0. So I know that the series should what? Diverge. Okay, so far, so good. The next one was to prove, starting from 3 to infinity, of negative 1 to the power of n times 1 over ln n minus 1. So they wanted to show the convergence. And the second thing was what? Find the maximum bound of S10. Okay. Was it S10? Sorry. Yes, it was S10. So look, let's check this out. Let's check this out. First of all, I want you to know the type of the series. What is the type of the series? It is infinite series, right? This is a type of series is alternating series. This is an alternating series. I'm very happy that this is an alternating series. So what you want to show is that either my sequence is decreasing. Is it decreasing? Yes, right? The ln is increasing function, but if you reciprocate, then the denominator is getting bigger and bigger, so the fraction itself is getting smaller and smaller. So we know that. Okay, so it is decreasing. And then the next thing I want to prove is the limit of the sequence, right? If you send n to infinity, this goes to 0, right? So we have decreasing sequence as well as converging to 0. So we are very happy. We are very happy. Okay, so far, so good. So far, so good. So since it is decreasing and goes to 0, I know my alternating series converges, period. Okay? The next thing we're going to show is to find his maximum bounds, right? But here's the thing, every time you have an alternating series and you're talking about the bounds, it's very likely that you're going to associate with the truncation error. You see? Remember, it was what was it? Sn partial sum and then the actual limit of the alternating series. I don't know what those values are, but I know their difference must be bounded by who? Absolute value of the next term of the sequence. Remember that? Very happy, very happy. So, I want to see the bounds, I want to see the difference between the 10th series minus who? The actual limit of the series, which we don't know. But I know by the truncation error that it's going to be bounded by who? Absolute value of A11, which is going to be same as 1 over ln 10, right? So that's it, right? Ln 10. So what you have to do is just plug that value and that's it, right? That's going to be your maximum bounds then. Understood? Right? Does it make sense? Because my sequence is him. This is my sequence. Come again? Natural log of what? Oh, 아니죠. Because it was my n was 10, right? And therefore, n plus 1 is 11. So you're putting the 11 to my sequence. My sequence here was what? 1 over ln n minus 1. So if you put 11, it's going to be 11 minus 1, hence 10. Okie dokie. So far, so good. And let's have a look at the next warm-up question, the one that I have got from your most frequently asked questions. So hold on a sec. I'm going to go to Question further. 죄송해요. Warm-up question. I already have collected them for the 9th of July. Yes, let us have a look at this. So this is a rather nice one. Your job is to find the Maclaurin series of tangent. Okay? Your job is to find the Maclaurin series of a tangent. Understood? Maybe you can do the 노가다. You know what I'm saying? Maybe you can do the 노가다. But you are not doing the 노가다. Okay? You are not doing the 노가다. You need to follow their order. What do they say? Find the series of a secant square in terms of A1, A3, A5 because you are given the tangent, right? And from tangent, how would you like to derive the secant square x? From tangent, how would you like to derive the secant square? I want to hear your opinion actually. So given that the tangent x is a1x plus a3x cubic a5x power 5, how would you like to derive the secant? Yes, some people attempted this by converting what? 1 plus tangent square. 하면은 너무 어려워지겠죠, 그죠? Because you gotta square that, you know? I don't want it. You know what I'm saying? But yes, as you've said, it's probably better to work with the derivative. So if you differentiate both sides, where you can differentiate term by term for the right hand side, you're gonna have a secant square. And what on the right hand side, I'm gonna have who? A1 plus 3, a3x squared plus 5, a5 x power 4 plus on and on and on. That's what I have on the secant square. Understood? Alright, so you know we've got that in terms of things is pretty fine. So that you know they asked me to do this by differentiation, and they also asked me to do by the substitution. Right? They said the secant square is 1 plus tangent square, and try to use that. Sure, why not? Okay, let's try that. So what I'm going to do here is to use the second approach is to use the expansion. Okay, so secant square is the same as 1 plus tangent square. Yes, you know this, yes? And what we're gonna do here is then, okay, so I'm gonna add 1 and then square tangent, where I'm given his first 3 terms, you see? Right? Okay, so then, and let's expand accordingly, so it's gonna be 1 plus. And this time, we'll be multiplying how many times? Twice, like that, yes? Okay, so in that case, 1 plus, if you look at the right hand side, how would you like to simplify this? By distribution, right? Let's do the distribution. So if I multiply by the first term, right, what's gonna happen? 근데 이건 아시면 편하죠. 뭐예요? a plus b plus c squared는 뭐랑 같죠? a square, b square, c square, right? 그 다음에 뭐예요? 2ab, bc, ca, right? So, you know, algebra, right? So what I have here is going to be a1 square, x square, right? a3 누구니까? x 뭐예요? 제곱 6, a5 n square x 10, right? And plus 2a1 a3 x power 4, right? 2a3 a5 x power 8 to a1 a5 x power 6, on and on and on, right? However, obviously, you know what we want to do is to compare with this, and for him we got, what is it, the constant term, square, and degree 4, right? So even though I have a crazy expansion with crazy power, maybe my interest is just constant, square, and quartic, right? Good. So I'm going to abandon quite a few actually. I'm going to only accept with the square and quartic. That's it, right? So I'm going to have a 1 plus a1 square x squared plus 2a1 a3 x power 4. And the rest is just, I'm going to put jump. So we have a two expression for the secant square. We have the secant square derived by the derivative. Yes. And then we have a secant square derived by using the trig identity. Okay. So this is by using the derivative, and this is by the trig identity. Okay.